Today we'll have a quick overview of how to interpret ABGs. So we're going to start out by actually giving you some normal values that we should see within the body. And after that, we'll go into conditions of acidosis and alkalosis. And finally, we'll learn about the differences between metabolic and respiratory acidosis and alkalosis, and finish up with this interpretation part. So this is a good website to actually use in order to get a lot of problems that will throw different types of scenarios at you so you can get really good at interpreting these ABGs. The website is abg.ninja/ABG. That's again, abg.ninja/ABG. So let's get started. First thing we want to know is the normal values that we should see within an individual. Right? The first of those being the blood pH. So we look at arterial blood. Arterial blood should be between 7.35 and 7.45. Right now, we do need to know some stuff within this range because it's the normal range, and anything outside that range is considered abnormal. Anything below 7.35 is what we term acidosis. Anything above 7.45 is what we term alkalosis. Now, 7.4 is perfect blood pH, right? Rarely do we have perfect blood pH. We're kind of banging back and forth between this 7.35 and 7.45 value. Now, if we are between 7.35 and 7.4, this is what we term acidotic lean, right? So this is still slightly low because it's not 7.4. It's not perfect, but it's still within that acceptable range. Now, above 7.4, between 7.4 and 7.45 is what we term alkalotic lean. It is slightly acidic, slightly more, alkaline, slightly more alkalytic than we want to be, but it's still within that range, so we're still okay, right? So now that we got that out the way, let's go into the next one, which would be the partial pressure of carbon dioxide. So this range is between 35 and 45 millimeters of mercury, being that we're dealing with pressure, right? So between 35 and 45 millimeters of mercury. Easy way to remember this, if you know the blood pH between 7.35 and 7.45, we can easily remember that the partial pressure of carbon dioxide is 35 to 45, 35, 35, 45, 45. Right, and the last value is the concentration of the bicarbonate ion, which should be between 22 and 26, what we call milliequivalents per liter. Right, so again, 22 to 26 milliequivalents per liter. Now realize again, when we're talking about conditions of acidosis or alkalosis, we're really just looking at the pH. Now the causes are either going to be metabolic or respiratory, but the pH kind of gives us an idea of whether we're dealing with alkalosis or acidosis. So if we look at this right here, and we look at our pH, we see that our pH is 7.46. Being that it is above that normal range of 7.45, we would term this alkalosis. So when actually trying to determine whether or not a condition is acidotic or alkalotic, we first look at that pH, right? So we know now this is alkalosis. So we can actually put that as our primary problem, right? Now we have to figure out whether it's metabolically caused or respiratorily caused, right? Now, in order to figure this out, we need a little bit more information, right? So this is going to take us to something else that is very useful, this little thing that we call ROME. So ROME stands for respiratory opposite metabolic equal. And when we're talking about opposite and equal, what we're really talking about is a direction of an arrow that we would put, whether it's either high or low. So if it's on the high side, right, then it will be an arrow up. If it's on the low side, then it will be an arrow down, right? We also have to kind of go back to those original pHs because we can have what we call acidotic lean in this area right here, which would still be a down arrow, and alkalotic lean in this area, which would still be an up arrow. So always remember that. Now, as we go back to ROME, right, we want to actually see what we're talking about when we're dealing with ROME. So if something is respiratory, we always look at two values. pH is always one of the values that we look at, whether it be respiratory or metabolic. The other value for respiratory would be the partial pressure of carbon dioxide. Now, when we look at metabolic concerns, we always look at the pH again, right? But then we look at the bicarbonate ion level, right? So now let's go back to our problem to see if we can figure out whether that primary problem would be respiratory or metabolic, right? So we already know that this pH is high, right? Being that it's high, we're going to put an up arrow for that. So you might want to have a piece of paper and actually follow along as we do this, right? Then the next one is the partial pressure of carbon dioxide, which is 19 millimeters of mercury. So 19 millimeters of mercury is below that 35 to 45 millimeters of mercury that it should be. So there we got a down arrow for that, right? And we're going to continue on this track and actually look at the bicarbonate ion concentration. As we look at that bicarbonate ion concentration, what we see is that it is 13 milliequivalents per liter, which is below what we should normally have, which is 22 to 26 milliequivalents per liter. Now we're going to figure this out. So the first thing we look at is the pH with respect to the partial pressure of carbon dioxide. And when we look at those two, we see that this arrow will be up while this arrow will be down. Now, if we go back to our Rome, we see that respiratory should be opposite. And since these are opposing with the pH being up while the partial pressure of carbon dioxide being down, we know that the primary problem here is respiratory. Now, we don't want to stop there. We always want to look at the pH also with respect to the concentration of bicarbonate ion. And we see that this is up while the bicarbonate ion concentration is down. So those are not equal. They are not going in the same direction, right? And since they aren't going in the same direction, it can't be metabolic. The primary problem is respiratory alkalosis. Now we have to kind of continue further and see whether or not this thing has compensation. So being that we use the pH and partial pressure of carbon dioxide to find the primary problem, we then go and look at the number that we didn't use, and that value that we didn't use is that bicarbonate ion concentration, and see that it is out of range. So what it is essentially doing is trying to fix the condition caused by the respiratory system. So if the respiratory system causes something, then the metabolic system will go to fix it. And if it is causing, the respiratory system is causing alkalosis, the fix would be acidosis. So what normally happens is the primary problem, the thing that's causing you the issue, respiratory alkalosis in this case, would be reversed or compensated by metabolic acidosis. So it's a common theme that you'll see that the primary problem, right, will have compensation that will be the exact opposite. So what is the opposite of respiratory? Well, it's metabolic. What is the opposite of alkalosis? Well, it's acidosis. Now, the final step is to figure out if the level of compensation is fully compensated or partially compensated. In order to figure this out, what we do is we look at the pH, right? We ask ourselves, is the pH within range? If the pH is within range, then it is fully compensated. If it's out of range still, then it's only partially compensated. So now is 7.46 within the range of 7.35 to 7.45? Well, no. So that means it is only partially compensated, right? So we click submit, and it actually tells us whether or not this answer is correct or not, and it is correct. And it also gives you an explanation if you do get it wrong or why you got it wrong and how you can actually fix your answering in the next question. So this gives you question after question. So let's go ahead do another one and see if we can figure this out. So the first thing again that we look at is that pH. That pH gives us an indication if we're dealing with acidosis or alkalosis. So we look at the pH, it's 7.5, which is above the range that is acceptable of 7.35 to 7.45. So that 7.5 is high, which would mean this would be alkalosis. Right? Now we have to figure out whether it is respiratory or metabolic. Now there's another one combined, and we'll get into that in another video. But right now we're just going to deal with respiratory or metabolic concerns. So first we look at the pH with respect to the carbon dioxide concentration, right? We see that this first number is going to be high, the pH, and then we look at the next number. So we see that 25 is going to be low. So that 25 millimeters of mercury is below that 35 to 45 that it should be. So that arrow will be down, right? And then we look at the next one, which is the concentration of bicarbonate ion. And that concentration is 19 milliequivalents per liter, right? If you remember, it should be between 22 and 26 milliequivalents per liter. So that arrow is also down because it's below that value that is required, right? So being that the pH and the carbon dioxide concentration, the partial pressure of carbon dioxide concentration are high and low, that would mean if we go back to Rome, they are opposite. So we know this is respiratory, but we still check the other one just in case, right? So the pH with respect to the bicarbonate ion concentration, we see that this is high and that this is low, right? But if we go back to Rome, we see that in order for it to be metabolic, it must be equal. So those arrows must be in the same direction. This is not the case. So what we do is we say, well, this condition is what we call respiratory alkalosis because these are opposite directions, right? Remember, respiratory is always dealing with pH and carbon dioxide concentration, and metabolic is always dealing with pH and bicarbonate ion concentration. Then we want to see if there is any compensation, right? Now, in order to figure out this compensation, again, what we do is we say, well, the two numbers that we use, the pH and the partial pressure of carbon dioxide, that caused the problem. Now, the other value would try to fix it. So is this value out of range? And yes, it is out of range. It is low. So since it is out of range, there is compensation. Remember, the compensation is going to be opposite of the problem. So if we have respiratory systems causing the problem, what would fix it would be metabolic. And if we have alkalosis being the problem, then the fix would be acidosis. Right now, the final step again is to figure out whether it is fully or partially compensated. In order to do that, we simply look at the pH. If the pH is within range, then it is fully compensated. If it is still out of range, that means you have only partially compensated back to the point where you were within range. So being that this is 7.5, which is still out of range, this is only partial compensation, right? You submit that answer and then you can see that it is correct, right? And it gives you the rationale behind that. So keep practicing these problems, and we're getting a little more detail as you start to get better with these ABG interpretations.